Let's go over how to do all the problems on quiz number 5. Number 1 said to solve the absolute value equation, show your work, and check for extraneous solutions. So first we want to get the absolute value symbol by itself. So let's first subtract the 9. So bring down 4 times the absolute value of x minus 5 is equal to 8. Then go ahead and divide both sides by 4 to get rid of the 4. And we get the absolute value of x minus 5 would equal 2. So from there, you want to set up your two equations, one positive and one negative. So we have, let me move these over where I have a little more room. So I'm going to set up a positive and a negative equation. So x minus 5 would equal 2 is my positive equation, and then x minus 5 will equal negative 2 is my negative equation. So one positive and one negative. Then all you gotta do is add the 5 to get x by itself. So x might equal 7. We'll check that in a minute. And then x plus 5, so x would equal 3. And then let's just check to make sure that that works. So we want to grab Desmos. And remember, there's two ways you can check your answer. You can type in the original problem just like it looks and check your x-intercepts. So it definitely looks like there's 2 of them, and they definitely look like they're at the right numbers, 3 and 7. If you wanted to make it look like an absolute value function, you can subtract the 17 to the other side, and you can click on them, and you definitely see that both of those are the right answers, and we have 2 of them. So we're all good with number 1. Number 2 says to solve the absolute value inequality, graph the solution and show your work. So let's get the absolute value symbol by itself, just like we do when we solve absolute value equations. That's always very important. So 9 times the absolute value of x minus 5 is less than 36. Then we need to get rid of the 9, so let's divide both sides by 9, and we get the absolute value of x minus 5 is less than 4. So then you want to set up a negative and a positive and a negative inequality. So I'm going to say x minus 5 is less than 4, and x minus 5 is greater than negative 4. Remember to change both signs for that negative one. So then we just want to add 5 to both sides, and we get x is less than 9, x is greater than 1. So if it's less than 9, it needs to have an open dot at 9 and go toward the numbers that are smaller than 9. And if x is greater than 1, it needs to have an open dot at 1 and shade toward the numbers that are greater than 1. So then to check our answer, we can once again just type in the original problem just like it looks, and it should give us a pretty good indication if we have the right answer. So notice it looks dashed on Desmos where we have our open dots on our paper, and it definitely looks like it's crossing at 1 and 9. So that all looks good. All right, for number 3, a company makes and boxes spaghetti. One machine fills each box with approximately 18 ounces of spaghetti. After the boxes are filled, another machine weighs each box. A box is discarded if the weight of the box differs by more than 0.75 ounces from the target weight of 20 ounces. And that should say 18. Write an absolute value inequality to represent the acceptable weights x of the spaghetti. So if all we need to do is write an absolute value inequality, they've given us the ideal amount, which is 18, and our tolerance, how much it can be off by, is the 0.75. So all we need to do is write it out in the form we've talked about. The absolute value of x minus the ideal amount is less than or equal to the tolerance, is all we need to set up. So I'm just going to write that there, and then all you needed to write was x minus 18 in absolute value is less than or equal to 0.75. And that's it. No more work is needed. Number 4 says write the equation of the graph below. State the vertex and all transformations from the parent function. Be specific. All right, so our vertex is located at 3, negative 2. And our a value, so our a looks like we got to go up to right 1. And it looks like it's definitely positive because the whole graph is opening up. So we can write out our equation. Y equals 2 absolute value of x minus 3 And then outside of the absolute value, we put the k value of -2. Remember, that's your h and your k in your vertex. The transformations go with those three things we just wrote. So a equals 2. That makes it have a vertical stretch by a factor of 2. So that came from the a value. The vertex helps us with the left or right. So the 3, you can also look over here. It looks like it did move right 3 from the center. So right 3 comes from our h value. And then also from the center or your origin, it moved down 2 to get to that vertex. So we want to include the down 2, which came from our k value. Remember, inside the grouping symbol, that goes to the right 3, down 2, and then that was our vertical stretch. And you have to say vertical because there are things that make it stretch horizontally. So if you don't say vertical stretch, it would be wrong. Number 5 says, Sarah said the equation for the graph below is y equals 2 absolute value of x minus 4 plus 5. Maya said the equation is y equals 3 absolute value of x minus 4 minus 5. Reggie said the equation is y equals absolute value of x plus 4 plus 5. And Travis said the equation is y equals 2 absolute value of x plus 4 plus 5. Who is correct and why? Give your explanation in a complete sentence. Make sure you state a reason that would make the person the only one with the right answer. Saying you typed it in Desmos would not be enough. All right, so let's see what we can figure out here. So I can tell that the vertex is located at -4, +5. So let's see who that would eliminate. So -4, +5. I know that I've got to have x plus 4 in the absolute value and plus 5. So that takes out Sarah. She would be wrong. Maya would be wrong. But we still have Reggie and Travis. So Reggie and Travis would still be correct because of their vertex. And then we can find our a value. So a looks like a +1. And Reggie has a +1 for his equation for the a value, where Travis has a 2. So you want to write out a nice explanation. So Reggie is correct because you could say his equation does not have a vertical stretch of 2, and it also has the correct vertex, or h and k, you could also name it that way, of -4, 5 represented. But you definitely have to help indicate that he's got the right vertex and that he does not have the a value equal to 2. Because if you say he has the right vertex, then Travis could also be correct. So that would not help. And then if you state the a value, it takes away Sarah being able to be correct because she's got an a value that's different than 1, and Maya also has an a value that's different than 1. So something about that vertical stretch or the a value has to be part of your explanation to help it make sure that Reggie was the only one that could be correct for this problem. All right, so that's it for quiz number 5.